Welcome to my channel Devish Mathematics. In this video we are going to discuss about the derivative of inverse trigonometric functions. And after the video, in the description link I will give a set of exercises which all of you have to practice for your upcoming examinations. Okay, let us start. All of you know dy by dx is nothing but limit delta x tending to 0 delta y by delta x, and this becomes useful when you have y in terms of x and you are asked to find dy by dx. But in certain cases, suppose you have a function which is a invertible, suppose f is invertible. When a function becomes invertible, that we are going to discuss in that we have already discussed. So y equal to f of x. So you start from x equal to f inverse of y. If you have a invertible function, then y equal to f of x would mean x equal to f inverse of y. If you make some change in y, suppose you get say y changes to y plus delta y, then x will change to x plus delta x. So what will be d by dy of f inverse y? This will be limit delta y going to 0 f inverse of y plus delta y minus f inverse of y divided by delta y. But what is f inverse of y plus delta y? If your y is changing to y plus delta y, then x is changing to x plus delta x. So f inverse y plus delta y is nothing but x plus delta x. And here you can also see when delta y is going to 0, delta x is also going to 0. So what is f inverse of y plus delta y? I can write limit delta x going to 0. This is nothing but x plus delta x minus x divided by delta y. X cancels. So what you get? Limit delta x going to 0, 1 of delta x by delta y. Or you can write it as limit delta x going to 0, 1 upon delta y by delta x. 1 is a constant, so this becomes 1 by limit delta x going to 0, delta y by delta x, but by definition that is nothing but dy by dx. So first and foremost important thing that you must learn is dx by dy is nothing but 1 upon dy by dx. This is very important. It will be used throughout your derivative chapter. So, in order to illustrate, let us work out a simple exercise. In order to illustrate the use of this formula, let us work out a simple exercise, very simple exercise. The exercise is given, dy by dx you have to find out, and when x equal to root y divided by 1 plus root y, right? Here you will see you have to find dy by dx, but x is given as a function of y and your original procedure won't work. So what you have to start, you have to essentially evaluate dx by dy. Dx by dy becomes d by dy of root y by 1 plus root y. So what is that? That is denominator, derivative of numerator minus numerator, derivative of denominator divided by denominator square. So what do you get? 1 plus root y, derivative of root y with respect to y is 1 by 2 root y. This is minus root y, derivative of 1 is 0. So you get this. right? So divided by 1 plus root y whole square. So what you get? 1 by 2 root y plus half minus half divided by 1 plus root y square. So this is nothing but your dx by dy. Therefore dy by dx becomes 1 plus dy by dx becomes, this becomes 1 upon 2 root y into 1 plus root y whole square. So dy by dx becomes 2 root y into 1 plus root y whole square. So this exercise is very important. You must learn how to use this. Suppose this exercise is given in the examination. How you have to solve this? Look, they are again asking you to prove dy by dx, but you cannot express y explicitly as a function of x. But you can express x as a function of y. So start from there. X equal to cos y divided by cos of a plus y. So what is dx by dy? Denominator, derivative of numerator minus numerator, derivative of denominator divided by denominator square. Cos of a plus y, what is the derivative of cos y? That is minus sin y, minus cos y. What is the derivative of cos of a plus y? That is sin a plus y minus, right? Divided by cos square a plus y. So what you get? Cos y sin a plus y cos y minus cos a plus y sin y divided by cos square a plus y. This is nothing but, this is dx by dy. What is this? This is sin a cos b minus cos a sin b, that is equal to sin of a minus b, y cancel, so you get sin a divided by cos square a plus y. So what will be dy by dx? Dy by dx will be cos square a plus y divided by sin a. So this exercise is very easy. Don't get frightened by looking at the exercise. The proof is easy, but you have to apply the correct formula. So the main aim of doing all these things is we have to find out the derivative of inverse trigonometric functions. First and foremost important thing, y equal to sin inverse x. You must remember x belongs to minus 1 to 1 and your y belongs to minus pi by 2 to pi by 2. This is by definition. So if y is sin inverse x, then what you get? X is equal to sin y. So what you get? Dx by dy becomes equal to cos y. So you get dy by dx equal to 1 upon cos y. What is cos y? Cos y is nothing but square root of 1 minus sin square y. Right? What is cos y? Cos y is 1 upon square root of 1 minus sin square y. They may write like this. So you get 1 by plus minus root of sin y is x. So this is 1 minus x square. But the most important point you must remember is y belongs to minus pi by 2 to pi by 2. So your cos y is positive. So the negative sign is ignored and the answer becomes, since y belongs to minus pi by 2 to pi by 2, cos y is positive, right? So the negative sign is rejected and you get dy by dx equal to 1 upon root 1 minus x square. Exactly the same way you start and prove. So I am not going to prove that. You just take it as an exercise. Y equal to say cos inverse x, and you can prove easily dy by dx is minus 1 by root 1 minus x square. This one is left as an assignment or homework. Right? Here in this case you must remember x is in R and your y belongs to open interval minus pi by 2 to pi by 2. It is not exactly in R, it is in minus infinity to infinity. Loosely speaking, it is in R. So y equal to tan inverse x would give x equal to tan y. So if you differentiate, dx by dy becomes derivative of tan y is sec square y, which is nothing but 1 plus tan square y, which is nothing but 1 plus x square. Therefore, dy by dx is 1 upon dx by dy, that is 1 upon 1 plus x square. This exercise, this is very very easy. And now I am leaving y equal to cot inverse x. You find the derivative. I am writing the answer. This is minus 1 by 1 plus x square. This is left as homework. Now come to the next thing. Y equal to sec inverse x. You start from y equal to sec inverse x. Here you must remember x belongs to minus infinity to minus 1 union 1 to infinity, and your y belongs to your y belongs to 0 to pi by 2 union pi by 2 to pi. So if you start, if your y is sec inverse x, then your x becomes sec y. So dx by dy becomes sec y tan y. So what do you get? Dy by dx is 1 upon sec y tan y. What is your sec y? Sec y is x. What is your tan y? Tan y is root sec square y minus 1, which is 1 by x root x square minus 1. Now the problem starts. You can see, when suppose you take your x to be greater than 1. When x is greater than 1, then your y belongs to 0 to pi by 2. And in that particular case, your tan y becomes positive. X greater than 1, that would imply your tan y is positive. So what will be your dy by dx? That will be 1 upon x root x square minus 1. This is when x is greater than 1. Now come to x less than 1. X less than 1 means your y is in pi by 2 to pi. That means what? Your tan y becomes negative. So what you get? 1 upon minus x root x square minus 1 when x is less than minus 1. Right? So now you combine both of them. So the answer becomes dy by dx equal to 1 upon mod x root x square minus 1. Now the next thing, y equal to cosec inverse x. Take it as an exercise. Prove dy by dx equal to minus 1 by mod x root x square minus 1. Now let us start solving some exercises. Before solving the exercises, you just make a note Derivative of sin inverse x 1 by root 1 minus x square. Derivative cos inverse x minus 1 by root 1 minus x square. Derivative tan inverse x 1 by 1 plus x square. Derivative cot inverse x minus 1 by 1 plus x square. Derivative sec inverse x 1 upon mod x root x square minus 1. Derivative cosec inverse x minus 1 by mod x root x square minus 1. I am starting with a very simple exercise question sin inverse 3x. Right? This exercise was asked carrying 2 marks in your winter 2019 examination. Winter or summer, I don't remember, but this was asked. So if this is given, what you will do? Y equal to sin inverse 3x. So dy by dx becomes derivative of sin inverse 3x 1 upon root 1 minus 3x whole square. And now you derivative make differentiation of 3x. So what you get? 1 upon root 1 minus x square. Derivative of 3x is 3. So the answer is 3 upon 1 square root of 1 minus 9x square. So you start with the next exercise. Say y equal to cot inverse root x. What you get? Dy by dx. The formula, suppose you take this as u. So what you get? Dy by du. Du by dx. So your y becomes cot inverse u. D by du of cot inverse u d by dx of u is root x. So what you get? Minus 1 by 1 plus u square. Derivative of root x 1 by 2 root x. So what you get? Minus 1 by 1 plus root x whole square 1 by 2 root x. So what you get? Minus 1 by 2 root x into 1 plus x. Thank you. In the description link of this video, I have given the link to a set of exercises which involves inverse trigonometric functions, and there are some exercises where you have to use substitution to get the derivatives. Work out them. Thank you. See you in the next time.